Hello everybody, this is the last video of the chapter 6.6. So if there was any concepts in the chapter that you haven't mastered or didn't understand, make sure to get help on those as soon as possible because we got that test coming up. In this video I'll be talking about solving one-step inequalities. A long time ago in a galaxy far, far away, we solved equations that look like this: x plus 7 equals 12. And you probably remember that to figure out what x is, we just need to isolate it by getting rid of the other stuff. So in this case, x is going to equal 5. Well, now that we know what an inequality is, we'll see that we can also solve inequalities. And they're done almost exactly the same way. For now, we're going to do them the exact same way. There's one thing that we need to learn in the future that will be slightly different, but we don't need to know it yet. So notice the problem that I've written here and the problem that I've written here are exactly the same, except for the equation or the equals sign changed to an inequality or a less than sign. So we're going to solve it the exact same way. Subtract 7 from both sides and we end up with x and 5, except instead of equals, it's less than. So the sign just stays the same. All right, so another example, y is minus 5 is greater than or equal to 13. Same deal, we're going to add 5 to both sides. And we end up with y is greater than or equal to 18. And that's it. It's pretty simple. Now let me do one more example here. A lot of people get used to having that variable on the left side, and they often don't know what to do when the variable's on this side. They're like, oh, should I subtract d? You can do that. You can really do anything you want to both sides of an equation, as we've talked about before, but subtracting d in this case doesn't help us get any closer to an answer. Remember, the goal is to isolate the variable, not move it around. And so we really need to get rid of this 14. So don't get used to having that variable on the left side every time. Problems are going to get more complicated as we move through the next couple years, so we need to be ready for anything. In this case, this 14 is over here. There's a couple different ways you can think about this. Now remember, when we started talking about integers, we talked about how when you have a number that has no sign in front of it, like this 14 here, it really is a plus 14. It's not just a 14. There's either positive 14s or there's negative 14s. There's no 14, okay? But over the years we've just decided not to use that symbol because it's just a waste of time. Everyone just thinks of it as a plus 14. And I think that might be an easier way to think about it. When you have this 14 here with nothing in front of it, we can still subtract 14 from both sides and it works out just fine. And so here we have d is less than or equal to 10. And you can plug it in and check it out, right? 10 plus 14 is 24. Another way you can think about this is that 14 plus d is the same as d plus 14. And I'll write it like this, right? Easy way to test that theory is to say, well, 14 plus 2, or any number, 14 plus 3, is 17. Well, 3 plus 14 is also 17. And so rather than freaking out about having this number in front here, you can just switch them around, make it look like that instead. The only problem with that is when you have a subtraction one like this y minus 5. Y minus 5 is not equal to 5 minus y. I can prove that by putting a 6 here, right? 6 minus 5 is 1. Well, 5 minus 6 is negative 1. That's not the same. So either way you want to think about it, this way or this way, is fine. Or if you have another way, that would be fine too. All right. Thanks for watching.